This is the AP prep session for Townview Magnet Center for the Dallas Independent School District. This video lesson is going to go over the 8 multiple choice problems chosen for position, velocity, acceleration. And so we're going to go over these 8 problems. First problem. A particle moves along the x-axis so that time t is greater than 0. Its position is given by function x of t equals 2t cubed minus 21t squared plus 72t minus 53. So what I'm going to do is just find the first derivative, because when we want to find the particle at rest, we can define the values of t for which x prime of t, the first derivative equals 0. So it's like the position and x prime of t is the velocity. So I'll just put v of t. And this is a non-calculator problem, so let's go ahead and find this first derivative. Take the derivative of 2t cubed is going to be 6t squared. The first derivative of negative 21t squared is going to be minus 42t, and the first derivative of 72t is going to be plus 72. And to find where the particle's at rest, we set the first derivative equal to 0. And what I'm going to do is take out a common factor from these 3 terms here, which is going to be the number 6. So 6 times what equals 6t squared? Well, that's going to be t squared. 6 times what equals negative 42t? That's going to be minus 7t. And 6 times what equals 72? That's going to be plus 12. 6 times 12 equals 72. So if we divide both sides of this equation by 6, we have 0 equals, and we're going to just factor this t squared minus 7t plus 12, so that's going to be quantity t minus 4 times quantity t minus 3. And so setting these 2 factors equal 0, we have t equals 4 and t equals 3. So that'll give us our answer choice E. So this is a very simple problem. Everybody, I hope, should be able to get this right. Problem 2 is a calculator allowed problem. The particle moves along the x-axis so that anytime t is greater than or equals 0, its velocity is given by v of t equals 3 plus 4.1 cosine of 0.9t. What is the acceleration of the particle at time t equals 4? Well, we got kind of a choice here. What we can do is we can take the first derivative of this and set that first derivative equal to 0 and solve using a calculator. But an easier way to do this would be to actually put this in the calculator. So we would have, to do that, I recommend going to, if you have a TI 83 or 84 series calculator, what you do, and the calculator I have is off screen. I've actually done the calculator work prior to making this video. You press the key math, and for derivative at a point, you then press the 8 key. And when you do that, you'll get a place you can enter. So what I did is, since this I used to enter d dx, you got to enter the x, and then enter the function. And because it took up too much room on my view screen, I did this in 2 stages. This is from the left, and this one on the bottom is from the right. And you can see the entering here of 4. And then after that, you press enter in your calculator, and you get this. Well, this one here to the nearest 1,000th place, or third decimal place, so it's 633, and it's going to be answer choice C. Next, problem 3. Particle moves along a straight line. The graph particle's position v of t at time t is shown for t is between 0 and 6. The graph has horizontal tangents at t equals 1 and t equals 5, and a point of inflection at t equals 2. For what value of t is the velocity of the particle increasing? Well, basically, velocity increases, okay, v of t is increasing where a of t, which is acceleration, equals v prime of t is greater than 0, or concave up. Now, when you talk about speed being increasing, you got to look for acceleration, velocity having the same sign. But for velocity increasing, it's just when acceleration is positive, greater than 0. And we have, I'm going to draw a number line right below. I tell my students that number lines are our friends. So if we draw a number line and put x double prime of t, which is acceleration, and we have a point of inflection at 2, right? T equals 2. So here at 2, and to the left of 2, between 0 and 2, we have concave up, and to the right of 2, we have concave down. And so between 0 and 2, and we say why? If we had to justify in the free response section, we would say because a of t equals v prime of t is greater than 0. So our answer choice A is the correct answer. Next, 4. Calculator problem. Particle moves along a straight line velocity given v of t equals 7 minus 1.01 to the power of negative t squared at a time t is greater than or equal to 0. Now, problem 2, we could have taken that first derivative and set it equal to 0, but here we would have, it'd be harder to take a first derivative of this. But the strategy is the same. You just go ahead and enter this, press TI-84 series calculator, press math 8, and then you just enter the function. I entered the function here, pressed enter, we get 0.054587 and so forth. Closest to answer choice D. You're not going to get that easy on your calculator section, your multiple choice on May 9th, but you may get one, and that'll be pretty fast and easy for you. Next, 5. Table below gives selected values of velocity v of t of particle moving along the x-axis at time t equals 0. The particle is at the origin. Which the following could be the graph position x of t of the particle for t is in the closed interval between 0 and 4. Well, what you have here is you look for where t is at rest. Okay, now t is at rest. It's going to be at a horizontal tangent line. So we got to have a horizontal tangent. At x equals 3. That's what it's going to look like. And so anything without a horizontal tangent, x equals 3. Here at h, we have x equals 2 with horizontal tangent, x equals less than 2. And then D is eliminated. So the only possibilities left are C and E. Next, if we look at, we got to look at our slopes, our next thing here. So at 0, we have a slope of -1. Well, it's pretty inconclusive because it looks like the thing is kind of going down from the get-go. That would, C or E could possibly be correct. Now we look at 1. At x equals 1, the slope of that function should be 2. Well, here at 1, looks like you have down here in choice E, it looks like you almost have another horizontal tangent line. whereas here at 1, you do have a positive slope. So that's going to eliminate answer choice E. So C is going to be your correct answer for problem 5. Next, we have particle moves along the x-axis. The velocity of the particle at time t is 6t minus t squared. What's the total distance traveled with particle from t equals 0 to t equals 3? Basically, what you're going to look for is you're looking for the initial position, and you're going to have a position function to do this. Well, x of t is going to be equal to the integral of x prime of t, which is the integral of v of t. And so the velocity is this 6t minus t squared. So x of t is going to be integral of 6t minus t squared dt. And I should have put dt up here, right? X prime of t dt, x prime of t dt. But so x of t, taking this integral, we have 6t squared divided by 2 minus t cubed divided by 3 plus c. Constant integration, we don't want it yet. And they don't give us a something, but we don't really need to know what c is. We can assume that it's 0 for these purposes. So x of t is equal to 3t squared minus 1/3 t cubed. And so if we find, I'm going to come up here, if we find x 0, we're going to get, plugging in 0 for all this, we're just going to get 0, right? And then if we want x of 3, we're going to get 3 times 3 squared minus 1/3, 3 to the 3rd power. And what that's going to be is 3 squared is 9. 3 times 9 is 27. And then we have minus 1/3 of 27. 1/3 of 27 is going to be 9. So 27 minus 9 is 18. So that'll be our total distance traveled, which is answer choice D. Next, problem 7. Particle moves along the x-axis with its position at time t given x of t equals point t minus a times point t minus b, where a and b are constants, and a is not equal to b, for which of the following values of t is the particle at rest. What I decided to do is to just, you could use a product rule, because you're going to need to find the first derivative and set it equal to 0, right? What I decided to do is to just multiply, expand this out. So t times t is t squared. You could use the product rule also. Then we have minus at minus bt. And then we have negative b times negative a, which is going to be plus ab. And x prime of t equals v of t, and that's going to be 2t, and then a is the constant. Well, t is to the 1st power, so we're going to get minus a, and minus the derivative of minus bt is going to be minus b, and the derivative of a and b multiplied together is going to be 0, because that's constant. And we set this, for finding one at rest, we set this equal to 0. So 0 equals 2t minus a minus b. And adding a and b to both sides of this equation, we have a plus b is equal to 2t. And dividing both sides of this equation by 2, we get a plus b over 2 is equal to t. And so that gives us answer choice B. Now sometimes with these letters, they can be a little bit confusing or intimidating, but when you understand that principle well of a constants, it's just, you just go through with it, act on some faith, and you get to your correct answer. Then we have this last one, this exercise set, for t is greater than or equal to 0, the position of the particle moving along the x-axis given by the function x of t equals sine t minus cosine t. What is the acceleration of the particle at the point where the velocity is first equal to 0? Well, what we're going to do is we're going to find v of t is equal to x prime of t. And that's going to be equal to the derivative of sine t is cosine t, and the derivative of negative cosine t is positive sine t. And then if we're going to need this later, so a of t is equal to v prime of t, which is equal to the derivative of cosine t is negative sine t, and the derivative of sine t is cosine t. Okay, now, to set this, to find where the particles at rest are equal to 0, we'll set 0 equal to cosine t plus sine t. And then to solve for this, if we subtract sine t from both sides, we get negative sine t is equal to cosine t. And say where that first happens. If we look at our unit circle of trigonometry, okay, we have over here at pi over 4, we have cosine t equals sine t, but over here, another quarter rotation circle at 3 pi over 4, we have negative sine t equals cosine t. They're the same, but in this case the sine would be positive and cosine negative. So where this would happen is at 3 pi over 4, because in this case negative sine t would be negative square root of 2 over 2, and cosine t would also be negative square root of 2 over 2. So this first happens at 3 pi over 4. It also happened down here at 7 pi over 4, but where it first happens is 3 pi over 4. So we want, so a of t, a of 3 pi over 4 equals negative, well, sine of 3 pi over 4 is square root of 2 over 2, plus cosine t, well, that's going to be plus negative square root of 2 over 2. So we have minus 2 square root of 2 over 2. 2 over 2 cancel. So we have our answer is going to be negative square root of 2. So that would be our answer choice A. So these are all the problems in the multiple choice version there. I hope this has been helpful to you. Good luck. Take a look at these free response problems also. Good luck on May 9th, and thanks for viewing.